did not name them.
I don't
I
think
do
it
not
was
have
you.
the power to change
I
it.
think it was you. You
It
did.
was me.
You were back there with Aristotle and Sophocles, and you. I'm sure those were mathematicians, and eventually you named them.
Okay, so tangent. You'll notice I have some different points in our table, and it'll become apparent once we do some of these. So 0 is actually here in the middle. What is the tangent of 0? Right, hand trail. Tangent square root of the top over square root of the bottom. So we get 0. Pi over 4 is like 45 degrees. That's radical 2 over radical 2, which is 1. Pi over 2 is 90. So that's radical 4 over radical 0, which is undefined. Okay, 3 pi over 4. That would be the same as pi over 4, but what quadrant is it in? 2. And in quadrant 2, tangent is negative. So it would be a negative 1. Okay, pi. That's the same as 0. So tangent of pi is 0. Okay, these negative angles, if you think back to your circle, pi over 4 is here. Negative pi over 4 just means you spun down, so it's really in quadrant 4. In quadrant 4, is tangent positive or negative? Negative, and the tangent of pi over 4 is 1. Okay, so at negative pi over 2, so you would be here. Yeah, that's the point 0, negative 1. Tangent is y over x, negative 1 over 0.
Undefined.
Negative 3 pi over 4, what quadrant would that be in?
2. Or 3.
3. In quadrant 3, tangent is positive, so we get a positive 1. And negative pi is the same as positive pi, which is 0. Okay, we're not used to really dealing with the negative angles. Usually we just add 2 pi and make them a positive, which you certainly could. Are you okay with that? But for our purposes of graphing, if we are going to have one smooth curve, this is like my 0, my pi over 4, pi over 2, negative pi over 4, negative pi over 2. And I know I have more points than that. We will add them here in a minute if we need to. So, tangent of 0 is 0. At pi over 4, it was positive 1. At pi over 2, it was undefined. What do you think that means?
There's a hole. It goes straight down.
Not a hole, but it's an asymptote.
Oh, yeah, that word. Did we learn that this year or last year? I don't remember.
Okay, at negative pi over 4, it was negative 1. At negative pi over 2, it was undefined, so that's an asymptote. And I have more points, but it just continues, so I'll get to those in a minute. Now, we could certainly put more in if we wanted to kind of figure out exactly what it was.
It's a diagonal line.
Yeah, it's not just a straight line here. If you think back, what happens at asymptotes?
Slopes way down.
Yeah, we are getting close to them.
Approaches.
We are approaching them. So you can see it's going up, and what's going to happen is it's approaching this asymptote. Never touches.
Wait, is it going to look like a, this is a third, square root of 3 function. Or a radical
cube root.
Or a cube function.
Similar, yes. And if we continue, we get the exact same thing. At 3 pi over 4, it was down to negative 1, and 0 would be positive 1. So this one would just keep repeating. Right? So now we kind of have a picture of what tangent looks like. I picked the weird intervals that I did because I wanted you to see the full curve of tangent. If we went from 0 to 2 pi, we would just have the chunks broken up with asymptotes in the middle. So I picked negative pi over 2 to positive pi over 2 to get one smooth curve. What is the period of this? How far is it from negative pi over 2 to positive pi over 2? Pi. And then after this, it's just going to repeat. So it repeats faster than sine and cosine. All right. Let's do cotangent. And you notice I have weird points again.
Oh no.
I went back to my 0 to 2 pi, and we'll see why in a minute. So cotangent of 0. So-
Undefined.
It's the square root of the bottom over square root of the top, so that's undefined. At pi over 4, it's radical 2 over radical 2, which is 1. At pi over 2, it's radical 4 over radical 0,
Undefined.
or sorry, radical 0 over radical 4.
Then
'cause
0.
It's 0. 3 pi over 4, quadrant 2, we know it's negative and be the same as pi over 4, so negative 1. What's going to happen at pi?
Undefined.
0. Oh yeah, yeah. 0.
Same as 0, yeah. 5 pi over 4, quadrant 3, cotangent is positive 1. And 3 pi over 2, it'll be back to.
0.
Okay, 7 pi over 4, in quadrant 4, cotangent is.
Negative.
Negative 1.
And 2 pi is the same as.
Undefined.
Oh, whoopsies. Okay, so they mirror. Kinda, not really. But it'll always go like 0, 1, 0, 1.
Yeah, those are the points we intentionally chose, so they were nice, but yes. So, at 0, it's undefined, so we start with a vertical asymptote. Okay, at pi over 4, it's 1. Pi over 2 is 0. 3 pi over 4, negative 1. And 2 pi is 0. Sorry, I said 0, but I did my asymptote. It's undefined.
Oh, I put that way too far.
So, we are seeing something very similar.
Should it be just pi?
So if I graphed mine from 0 to pi, it's already repeating. What do you think would happen if I went all the way to 2 pi?
Repeat.
It repeats. If we look at my points, undefined, 1, 0, negative 1, undefined, it's the same thing as we got the first time. So just like tangent, it only has a period of pi. That's how long it takes to start repeating itself. Both of these are a nice curve, but they have asymptotes that we have to look at. So tangent has asymptotes. We go from negative pi over 2 to positive pi over 2, so that it's asymptotes at the end, 0 in the middle. Cotangent, we go from 0 to pi. Asymptotes at the end, 0 in the middle.
I don't think I'm graphing this right. Can you take a peek? I think this is too.
You have too many curves.
Yeah.
So this is just like,
Okay. I curved it the wrong way.
Yeah.
Got it. Thanks.
Alright. My suggestion on tangent and cotangent, if you're having a hard time getting your graphs to curve enough, try making your x-axis points closer together. That helps a little bit when it's less stretched out. It's easier to curve. So last thing I want to do today is just decide if these things are even or odd. So remember, we talked about this with sine and cosine. If I looked at tangent, even means symmetric to the y-axis. If I flip this over the y-axis, does it overlap itself?
No.
No. Odd means symmetric to the origin. If I flip over the y and the x, does it overlap?
Yes.
Yes.
Yes. So, just like sine, tangent is odd. That means if you have a negative, we can take it out in the front. Okay, let's look at cotangent. So with cotangent,
It's the same.
if we were to continue this, we're going to be doing the same thing over here, so is this even or odd? Also odd. To be even, it would have to be a mirror image on the other side of the asymptote, and it's not. But if I flip, then it would overlap. So far, the only even function we've seen is which one?
Cosine.
Cosine. The rest of these are odd functions.
I don't even know what even cosine does. I just know negative go places.
Okay, so basically if it's even, it's saying whether x is positive or negative, you get the same value. It works for cosine because cosine is positive in both quadrants 1 and 4.
So it's
So
if
whether
my,
you spin up or spin down, you're getting the same
it's
value.
if my what's it, coefficient over x is negative. We just haven't had
Yes.
one of those yet.
Yes.
Okay.
Okay, this is where we're stopping for today. On Tuesday, we will